Okay, today we will be looking at how to, this is the beginning of chapter 7. This will be the first topic. This is a 2-day topic. We'll be looking at how to graph exponential functions. Exponentials are a different type of functions than the ones we've been seeing, and they model situations where value either increases or decreases very rapidly. So an example of something that's growing exponentially would be like the population or stock market, the value of antiques, land value, etc., tuition prices, rates, anything that grows as a percentage of its value is exponential. So you hear of stuff growing by like 10% each year or 12% each year. That's an example of exponential. Decay would see something that simply decreases in value or size over time at a specific rate based on a percentage. So the population of endangered species, population after a plague, value of assets, effects of medication, that kind of stuff. First thing we're going to look at for exponentials is we're going to look at how to graph exponentials. The standard form of an exponential function is y equals a times b to the x minus h plus k. There's a lot of different values here besides the x and y that we could have. We could have an a, a b, an h, a k. Exponential growth, this type of equation would be an example of exponential growth if the a is positive and the b value is greater than 1. So for example, this equation right here would be an example of exponential growth because the a value is 0.3 and the b value is 2. So the a value is positive and the b value is larger than 1. The next equation right here would be an example of exponential decay because the a value is positive, a is 4, and the b value is between 0 and 1. Okay, it's 0.2, that's between 0 and 1, which means that it's decreasing. If the a value is negative, because in both these cases, growth and decay, the a value is positive, if it is negative, then we don't refer to it as growth or decay, we just say that it's an exponential. So how do we actually graph an exponential function? The first thing we do is graph the horizontal asymptotes. Okay, this is going to be a dotted line that the graph will never cross. It's a horizontal line that the graph will never cross. And we just draw it like this, like that. It never crosses that line, and that line is always equal to the k value. Okay, it's the y equals k. Next, we set the exponent equal to 0. So whatever the exponent is, we set it equal to 0. And then solve for x. And whatever that x value is, it will be the middle of our table. We'll be graphing this using a table. That will be the middle of our table. We will then choose 2 x values above that value and 2 below, and then substitute them into the y values to create points. Once we have the points, we'll plot them, put arrows on them, and that will be our graph. Let's look at this first one. So my a value here is 1, because it's not written. My b value is 3, it's the base of the exponent. My h value would be up here with the x, there's nothing up there, so it's 0, and my k value is negative 2. So since my a value is positive and my b value is greater than 1, this would be exponential growth. Next, my horizontal asymptote. My horizontal asymptote is going to be y equals k. So it's going to be whatever the k value is. So the k value is negative 2. So I'll put a dotted or a dashed horizontal line that goes through negative 2 like this. So my graph will never cross that line. Okay, so I want to fill out my table, and I'm going to start with the middle of the table. The middle of the table, the x value should make the exponent equal to 0. Okay, so the exponent right now is x, just x. So I set the exponent equal to 0 and solve. So set the exponent equal to 0. So x equals 0. And there's nothing to solve here, so 0 is where I'm going to start. And then I want two values to the right, so 1, 2, and then two values to the left, -1 and -2. And now I'm going to use my equation and my table, and I'm going to plug each of these x values into the equation. So my equation, 3 to the x power minus 2, I'm going to plug each of these x values into this equation to fill out the y values. So first I will do -2. -2 is the first thing in my table. So I'll do y equals 3 to the -2 power minus 2. We can use a calculator for this if we want. 3 to the -2 power. 3 raised to the -2 power is 0.1 repeating. I'll do 4 decimal places, so 0.111 minus 2. So I'll subtract 2. Whoops. -1.8 repeating. Okay, so that will be the first value in my table. So right here, -2, -1.8. I'll just leave it like that because it doesn't have to be perfect. So I'll just leave it like that. Next, I'm going to plug in -1. All right, so let's plug in -1. So y equals 3 to the -1 power minus 2. I can put this into a calculator. 3 to the -1, that's 0.3333 minus 2, which is -1.6666, repeating. It just keeps going. But I'll just round that off, -1.6. Doesn't have to be perfect. Let me go back to my table. -1.6. Okay, next I want to plug in 0. Wait a minute, I think I made a mistake here. Let me try that. Let me actually use a calculator for that, make sure I'm correct. So 3 to the -1 power minus 2, yeah, -1.667. Oh, okay, never mind, I know what I'm doing. All right, next I'm going to plug in 0. So y equals, did I put it in the table? Yeah. Y equals 3 to the 0 minus 2. 3 to the 0, you could put that in a calculator, but it is going to be 1 because anything to the 0 power is 1. And 1 minus 2 is -1. So next in my table, I have 0, -1. Okay, let's plug in 1. It's a bunch of plugging in. So 3 to the 1 minus 2, which is just 3 minus 2, which is 1. So next, 1, 1. And then I need to plug in 2. So 3 to the second power minus 2, which is 9 minus 2, which is 7. So next on my table is 7. All right, now I've got all my points. I'm going to graph them and connect them to make my exponential. So -2, -1.8, like right here. Do a different color. -1, -1.6 is like right here. 0, -1 is right here. 1, 1 is right here. And 2, 7 is right here. Look how quickly it goes up. So on the right side, it goes up very steeply, like this. On the left side, it comes down, gets very close to this dotted line, but never actually crosses it. So something like that. It gets closer and closer to it, but never actually crosses it. So our exponential looks something like this. And this is what most exponential functions will look like. All right. Our domain here, well, our domain is all real numbers. It goes infinitely to the left and infinitely to the right, so negative infinity to infinity. The range, however, is not infinite because it stops here at -2. So we would say that it's from -2 to infinity. And we put a parenthesis on the -2 because it doesn't actually touch -2. It gets close to it, doesn't touch it. All right, next we have y equals 4 parenthesis times 1/2 to the x power. So our a is 4, our b is 1/2, our h, there's nothing up here with the x, so that's 0, and there's nothing over here, so the k is also 0. So this is going to be exponential decay. We know it's decay because the b value is between 0 and 1, it's 1/2. The horizontal asymptote is always equal to k value, so it's y equals 0. The k value is 0, which means that it's going to, the asymptote here is going to be at 0. So the graph is never going to cross that dotted line. As far as the table, we're going to start in the middle. So this should be whatever will make the exponent equal to 0. Well, the only thing that's in the exponent is x. So we set the exponent equal to 0, x equals 0. So 0 goes in the middle. Then we have 2 to the right, 1 and 2. 2 to the left, -1 and -2. And then we plug each of these in to the equation. So y is equal to 4 times 1/2 to the x. And unplug each one of these points, each one of these x values into the equation. Get rid of this stuff. All right, so let me start with -2. That's the first thing in my table. And plug in -2. So I got y is equal to 4 times 1/2 to the -2 power. We can use a calculator for this. 1/2 to the -2 power. I can put that into a calculator. That would be 4, which gives us 16. So the first point, plugging in -2, gives us 16. All right, let's plug in -1. So y equals 4 times 1/2 to the -1 power. We can plug that into a calculator. We'll get 2, which is 8. So the next point, -1, comma 8. All right, next we plug in 0. Y equals 4 times 1/2 to the 0 power. That 1/2 to the 0 power is just 1, and 4 times 1 is 4. So 0, comma 4. Next we'll plug in 1. So y equals 4 times 1/2 to the 1 power, which is just 4 times 1/2, which is 2. So next we have 1 comma 2. Lastly, we'll plug in 2. Y is equal to 4 times 1/2 squared. You can put this into a calculator or you can just do it like this, okay? Either way, put it into a calculator, you'll get 0.25. And 4 times 0.25 is 1. All right, now we have all our points. We can graph them. So we'll start with -2, 16. Okay, that's not going to fit, so we'll just won't worry about that. -1, 8, which is right here. 0, 4, which is right here. 1, 2, which is right here. And 2, 1, which is right here. Okay, so this one actually looks different from the last one because this one's coming down on the right side and it's going up on the left side. And that's because this is decay. Okay, so it's getting smaller as opposed to getting larger. It's still exponential, but it's decay. The domain for all of these is the same, -infinity to infinity. But the range, however, is limited because it doesn't go on forever. It actually stops here at this dotted line. It stops at 0. So we would say the range is from 0 to infinity. All right, we got 2 graphs we are doing for the assignment. Make sure you follow all the instructions.